For 72 seconds on the night of August 15, 1977, a radio telescope in Ohio recorded a signal from the direction of Sagittarius. So strong, so narrow, so precisely tuned to the exact frequency scientists believed an alien civilization might use to say hello, that the astronomer who found it could only write one word in the margin. Wow. It has never come back. You're listening to The Unlit Room. Every story in here actually happened. That's the part that should scare you. New stories every day, Monday through Saturday. This episode's narration is AI-generated. The research, writing, and editorial decisions behind every story are made with care for accuracy and respect for those involved. Today, the signal that appeared once, ticked every box, and vanished. Delaware, Ohio. 1973. A massive radio telescope called Big Ear, 3 football fields long, built from wire mesh and aluminum, is reassigned to a new project, listening for extraterrestrial intelligence. John Crows built it. He's a radio astronomer who spent years constructing this thing from scrap and university funding. Big Ear isn't glamorous. It's a fixed reflector, 2 long rectangular aluminum panels on the ground, tilted to catch radio waves from the sky, and a movable flat reflector that bounces signals into the feed horns. It can't track objects across the sky. It can't pivot. It just stares at one strip of the heavens and waits for the Earth's rotation to do the work. It's a long-shot science experiment most people have never heard of. Krause knows the odds, but he points the telescope at the sky anyway and starts recording. Every day, every night, listening for something that might never come. Big Ear operates on a simple principle. It listens to a narrow slice of sky, about 2 degrees wide, as the Earth turns beneath it. Anything out there, a galaxy, a pulsar, a transmission from someone else, sweeps through the telescope's beam in about 72 seconds. Then it's gone, carried past by the planet's rotation. The observatory scans 50 channels at once, covering a range of radio frequencies. Every 12 seconds, the system records what it's hearing and punches the data onto computer tape. Later, that data gets printed onto green and white fanfold paper, the kind that tears along perforated edges, stacks waist-high in university offices. The printouts are rows and columns, thousands of them. Each number represents signal intensity. Background noise from space, hydrogen clouds, distant quasars, the faint electromagnetic hum of the universe usually comes in as 1s and 2s. Low single digits, static. The numbers are meaningless unless you know what you're looking for, and what they're looking for is this: something that doesn't belong, something narrow, something at the right frequency. Something that rises and falls the way a real celestial source would as it passes through the beam. Most nights, there's nothing. Just noise. Micro Cliffhanger 1. A few days after August 15, 1977, Jerry E. Eman, a volunteer astronomer, sits down with a stack of printouts. He's looking for anything unusual, anything that stands out. And then he sees it. One vertical column leaps off the page. Not a 1 or a 2, not even a 5, 6, EQUJ, 5. The observatory uses a simple code. Numbers represent signal intensity. When the intensity gets too high for a single digit, the system switches to letters. A is 10, B is 11, and so on. The sequence Eman is staring at translates to intensities in the 20s and 30s, more than 30 times stronger than the background noise. The signal rose smoothly, peaked at U, an intensity of 30, and fell back to nothing. Over 72 seconds, exactly the profile you'd expect from something in the sky passing through a fixed beam as the Earth turns. Not a glitch, not interference bouncing around inside the building. Something out there. Eman picks up a red pen, he circles the string of characters, and in the margin, because there's nothing else to say, because the numbers speak for themselves, he writes a single word. Wow. There's one more detail about this signal, one detail that made every breath in that room catch when people started putting the pieces together. SETI, the search for extraterrestrial intelligence, had always been based on an educated guess. If someone out there wanted to send a message, what frequency would they choose? You'd want something universal. something any technological civilization would recognize. A cosmic meeting point. The answer, theorists agreed, was 1420 megahertz, the frequency of neutral hydrogen, the most abundant element in the universe, the one thing every civilization with radio telescopes would be listening to. The WOW signal came in at 1420.4 megahertz, right next to the hydrogen line, close enough to be intentional, close enough to say, if you're listening, this is for you. It was narrowband, meaning it wasn't spread across a wide range like natural radio sources. Pulsars flicker, quasars hum across the spectrum. The WOW signal was focused, a single clean frequency. The kind of thing you don't get from a star or a gas cloud. And it came from deep space, from the direction of the constellation Sagittarius. Not from Earth, not from a satellite, from out there. It matched the theoretical profile SETI had been searching for since the project began. All of it, the frequency, the bandwidth, the duration, the intensity, the celestial origin. This was exactly what they were looking for, so they did the only thing they could do. They pointed Big Ear back at the same patch of sky, and they waited. Micro cliffhanger too. Nothing. They tried again the next night, and the night after that. Nothing. Over the next decade, astronomers returned to that region dozens of times. Mann himself led searches in the late 1980s. Robert Gray, an independent researcher who became obsessed with the signal, spent years chasing it with different instruments. He used arrays more sensitive than Big Ear. He covered wider frequency ranges. He accounted for the Earth's movement around the Sun, the possibility of drift, the chance that the source might have moved. He searched the same patch of Sagittarius again and again. In 1995, in 1997, in 1999. He even wrote a book about it, a methodical, almost desperate attempt to understand what happened that night in August 1977. They scanned both of the possible positions on the sky. Because Big Ear had two feed horns that looked at slightly different points at once, and the WOW signal had appeared in only one. They checked for interference. They ruled out satellites, reflected signals, terrestrial radio sources. Gray's searches turned up nothing. Neither did anyone else's. The WOW signal never repeated, not once. A signal loud enough to make an astronomer stop mid-review and scrawl WOW in the margin, a signal that hit every theoretical marker for an intentional transmission, came exactly once. 72 seconds, and never again, ever. In 1998, the Big Ear telescope was dismantled. The land was sold. Ohio State needed the space. It's a golf course now, the instrument that recorded humanity's most famous unexplained cosmic signal, the one data point that comes closest to what SETI was built to find, no longer exists. For 40 years, people have tried to explain the WOW signal away. In 2017, a researcher named Antonio Paris proposed that the signal came from a comet, specifically from a cloud of hydrogen gas around Comet 266P. The timing seemed to fit. Comets do release hydrogen, and if you squint at the data, you can make the comet's position line up with the patch of sky Big Ear was watching that night. It sounded like an answer, a natural explanation, case closed. But the original team, Mann included, rejected it almost immediately. Comets are faint radio sources, diffuse, weak. The WOW signal was loud, focused. More than 30 times stronger than background noise. A comet wouldn't produce that kind of intensity at 1420 megahertz. And here's the detail that quietly dismantles the comet explanation. Big Ear's two feed horns looked at slightly different patches of sky at the same time. The WOW signal appeared in only one of them. If the source had been a nearby comet, something inside our solar system drifting through the beam, it should have shown up in both horns. A hydrogen cloud big enough and bright enough to produce the WOW signal would have been visible to both receivers. It didn't. It was in one, not the other. The comet theory collapsed under its own assumptions. And the mystery stayed open. There's a detail most people miss when they hear the WOW story, a detail that narrows every explanation and deepens the question at the same time. The signal appeared in only one of Big Ear's two feed horns, not both, one. That single asymmetry rules out broad sources like comets or distant interference. It suggests something focused, something directional, something small and far away, or something that was only transmitting for 72 seconds. Long enough to be noticed, not long enough to be confirmed. If it was a beacon, it was the quietest beacon imaginable. One sweep, one pass, and then silence. Jerry E. Mann spent decades after 1977 being careful with his words. He never claimed first contact. He never called it proof. When people asked him what he thought the wow signal was, he gave the same answer every time. We just don't know. That's the discipline of not knowing. The hardest kind. He could have built a career on speculation. He could have claimed certainty. He could have written a book declaring that humanity had finally heard from someone else. Instead, he circled a string of letters on a printout, wrote one word, and let the question sit. The most tantalizing signal humanity has ever detected from space is also the most unconfirmable because it came exactly once. A single data point, no follow-up, no repeat. Just 72 seconds of something we still can't explain. The telescope is gone, the printout remains. A circle of red ink around 6 characters, and a question we still don't have an answer to. Maybe it was interference. Maybe it was a comet no one's been able to match to the data. Maybe it was a natural astrophysical source we haven't discovered yet. Or maybe for 72 seconds in 1977, someone out there said hello, and we missed our chance to answer. If this one kept you up tonight, good. New stories every day, Monday through Saturday. Subscribe so the next one finds you too. That was the Unlit Room. See you in the dark.